Hi everyone, I am Siddharaju, Assistant Professor of Chemistry. In this session, I am going to discuss about the electronic effects, particularly about the electromeric effect and mesomeric effect. It is there in the syllabus for the BSc first semester. The title of the paper is Chemistry 1 DSc 2A. Let me consider electromeric effect. Just go through this equation. I have taken an unsaturated compound. It is represented like this: A double bond B. There are two covalent bonds between A and B. Among them, one is essentially a sigma bond and another one is a pi bond. And this molecule is neutral as neither of the atom is having a charge. When this substrate gets attacked by a reagent, the electron pair forming a pi bond transfers completely to one of the multiple bonded atom, either towards the B or towards the A. Here I have mentioned the electron pair forming a pi bond move towards the B. As a result of this, we are getting this species: A with a positive charge, single bond, B with a negative charge. A polarity is produced in the molecule. So when you remove, or if you remove the attacking reagent, this species will get converted back into a neutral molecule. That means this effect is temporary. It operates only in the presence of attacking reagent. This effect is called electromeric effect. That means the effect which causes temporary polarization in the molecule having a multiple bond by the complete transfer of electron pair forming pi bond to one of the bonded atoms is called electromeric effect. So the point to be remembered here are, it is a temporary effect because it operates only in the presence of attacking reagent. It is observed only in those organic compounds which are having a multiple bond. You cannot get it in saturated compounds. And it involves the complete transfer of shared pair of pi electrons to one of the atoms joined by a multiple bond in the presence of attacking reagent. So electromeric effect are of two types. One is positive electromeric effect and another one is the negative electromeric effect. Let me consider positive electromeric effect. It is also indicated like plus E effect. So for this I have taken this equation. You just look at this equation. I have taken an alkene and I have considered a attacking reagent H plus, a species with a positive charge. When this species approaches the substrate, the electron pair forming a pi bond transfer to one of the multiple bonded carbon atom. Here you look it carefully. This H plus ion being attacked to this carbon, then the moment of electron pair forming a pi bond takes place to this carbon only. As a result of this, it is giving a positively charged species. This effect is called positive electromeric effect. That means the electromeric effect, which involves the transfer of electron pair forming a pi bond to the multiple bonded carbon atom to which the reagent gets attached, is called positive electromeric effect. It can be observed when the attacking reagent is an electrophile. See, positive electromeric effect is observed only when an electrophile approaches the unsaturated compound. The second one, a negative electromeric effect, which is also indicated like minus E effect. For this I have considered this equation. I have taken an alkene and Cn minus is the attacking reagent. When Cn minus approaches this alkene, the electron pair forming a pi bond transfers completely to one of the carbon atoms. So you look at this, you carefully look at this reaction. So the Cn minus being attached to this carbon atom and the transfer of electron is towards the another carbon atom. As a result, it gives a species with negative charge. This effect is called negative electromeric effect. That means the electromeric effect, which involves the transfer of electron pair forming a pi bond to the multiple bonded atom to which the reagent is not get attached. So this is what we call negative electromeric effect, and it can be observed when the attacking reagent is a nucleophile. Well, Let us consider the significance of electromeric effect. The concept of electromeric effect can be used to explain the electrophilic and nucleophilic addition reactions of unsaturated compounds. So, let me take an example for the electrophilic addition reaction. You take a alkene. When this alkene is made reacts with hydrogen bromide. So, the HBr is going to add across the double bond and gives a respective alkyl bromide. Here in HBr, H is having partial positive charge and Br is having partial negative charge because of the inductive effect. When this reagent approaches the substrate, the pi electrons, the electron pair forming a pi bond, transfers completely like this. See, it will approaches the reagent and it will take up the proton and gives Br minus. See here, it is carbon, then it is a single bond, again carbon, carbon, hydrogen will get attached to this carbon atom, and this carbon is going to have a positive charge because it loses the pi electron and gives Br minus. You look at this step. So, here the reagent approaches the substrate, thereby the transfer of pi electron takes place to one of the carbon atom and results with a species of positive charge. This is what positive electromeric effect you can observe. So, then this Br minus links to the carbocation to give respective alkyl bromide. Then H. So, now let me consider another example. It is a nucleophilic addition reaction. I am going to take aldehyde. So, when the aldehyde is made react with hydrogen cyanide, it gives a respective cyanohydrine. So, here it generates a nucleophile Cn minus. So, it will attacks the carbonyl carbon and displaces the pi electrons. So, it will be like this, R C single bond, it is O minus, then it is Cn, then it is H, and there is a proton from HCN. So, you look at this step. As the attacking reagent approaches the carbonyl carbon, the transfer of pi electrons takes place towards the oxygen, results with a negatively charged species. This is what negative electromeric effect. Then it takes a proton to give respective cyanohydrine. This is what the significance of electromeric effect. Before going to study about the resonance effect in detail, let us have a knowledge of resonance structures. Sometimes it is not possible to assign a single Lewis structure for a molecule which can satisfactorily explain all the properties of a compound. In such cases, the molecule is represented by the two or more Lewis structures. Each one of them can explain most of the properties of a compound, but none of them can explain all the properties of a compound. These structures are called canonical structures or resonance structures. These structures are differ in the position of electrons, but not in the relative position of atoms. The actual structure of a compound is the hybrid of these resonance structures. Let me consider an example of benzene. The actual structure of benzene is the resonance hybrid of these two structures. Now, let us consider resonance effect. It can be explained by considering this electronic interactions. See, in the first case, there is an interaction between the pi bond and lone pair of electrons, and in the second case, there is an interaction between the lone pair of electrons and the pi bond. In the third case, there is an interaction between the pi bond and pi bond. All these kind of interactions leads to a polarity in the molecule, and this is what we call resonance effect. That means the polarity produced in the molecule due to the interaction of two pi bonds or between a pi bond and lone pair of electrons present on an adjacent atom is called resonance effect. The main points to be remembered in case of resonance effect are: it is a permanent effect, it is caused by the displacement of lone pair of electrons or pi electrons, and the most important one, it is observed in the conjugated system. Then there are two types of resonance effect. One is positive resonance effect and another one is the negative resonance effect. Let me consider the positive resonance effect, which is indicated as plus R effect. We can understand by considering this example. Here I have taken a benzene ring. It is a conjugated system to which the NH2 group is attached. You just look at this molecule. There is a lone pair of electron on the nitrogen which is moving towards the benzene ring, and it gets stabilized by these resonance structures. So this effect is called positive resonance effect. That means the resonance effect, which involves the transfer of electron away from the atom or group which is attached to the conjugated system, is called positive resonance effect. The groups that can show the positive resonance effect are OH, OR, SH, SR, NH2, etc. Now let us consider negative resonance effect, which is indicated by minus R effect. Let us have an example of nitrobenzene. Here the NO2 group is attached to the benzene ring. Here look at the movement of electron. The electrons are moving towards the group attached to a conjugated system, and it gets stabilized through the resonance. This effect is called negative resonance effect. That means the resonance effect, which involves the transfer of electron towards the atom or group attached to a conjugated system, is called negative resonance effect. The groups that can show the negative resonance effect are NO2, carbonyl group C double bond O, or CN, COOH, etc. Now let us consider what are the significances of this resonance effect. So under that, the first one is dipole moment. The concept of resonance can be used to explain the dipole moment in some compounds. The best example is this one. I have considered vinyl chloride here. So just have a look. So the dipole moment for this CCl bond in the case of vinyl chloride is 1.4 dB. Actual dipole moment of CCl bond, it is 1.5 dB. So here it is less than this, it is 1.4. It can be explained on the basis of a resonance. As we know that there are 3 lone pair of electrons on the chlorine, so which can be involved in the delocalization like this. So as a result of this single bond is going to have a partial double bond character. As a result of this, the dipole moment decreases. Then the another importance of this, we can use the concept to explain the bond length. So look here, this is the benzene. So when you look at these resonance structures, both of them are having 3 carbon-carbon double bonds and 3 carbon-carbon single bonds. See, there are 3 carbon-carbon single bond and there are 3 carbon-carbon double bond. When you examine these structures for the bond length, you are supposed to get 3 carbon-carbon single bonds with a bond length 154 picometer and 3 bonds with 134 picometer. But you cannot get this one because the actual structure of benzene is the resonance hybrid of these two. Here all the 6 carbon-carbon bond length are similar or same. It is 139 picometer. It can be explained only on the basis of a resonance. And the one more importance of this resonance effect is we can use this concept to explain the strength of acids and bases. Let us consider an example of acetic acid. The acetic acid have the tendency to get ionized and produce H plus ions. So the substance which can produce a proton are called acids. So here we can explain the acidic strength of this or acidic nature of the acetic acid by considering a resonance effect. See here, acetic acid ionizes to give acetate ion and a proton. The acetate ion which is formed gets stabilized through the resonance. Hence, acetic acid wants to get ionized as acetate ion, the more stable acetate ion, and gives H plus ion. Hence, it behaves as a acid. And we can use the concept of resonance to explain the basic nature also. See, I have taken aniline and cyclohexylamine. Among these two, cyclohexylamine is more basic when compared to the aniline, because here the lone pair of electron present on the nitrogen is easily available for the protonation or reaction, whereas in case of aniline, the lone pair of electron present on the nitrogen are involved in the delocalization towards the benzene ring. Hence, they are not freely available for the protonation or reaction. Hence, it is less basic when compared to the cyclohexylamine. The concept of resonance effect can be used to explain the reactivity and orientation of electrophile on substituted benzene ring. So, it can be better understood by consider an example of benzaldehyde. So, when benzaldehyde is subjected to electrophilic substitution reaction, the substitution occurs at the meta position rather than the ortho and para. So, this can be explained on the basis of a resonance effect. Let us consider a benzaldehyde. Here the oxygen is more electronegative when compared to the carbon. So, it pulls the shared pair of electron towards itself. In turn, this carbon pulls the pi bonded electrons of benzene towards itself. As a result, the positive charge is developed at the ortho position and it gets stabilized through the resonance like this. If you look at these three structures, resonance structures of a benzaldehyde, the positive charge is on ortho and para position but not on the meta position. That means the meta position is relatively rich in electron when compared to ortho and para. As a result of this, the electrophile attacks the meta position rather than the ortho and para. So, that is why benzaldehyde on electrophilic substitution reaction gives meta substituted products rather than the ortho and para. So far, in this class I have discussed about the electromeric effect and its significance, resonance effect and its significance. Hope you understood the concepts. In the next class, I am going to explain about the hyperconjugation. Thank you.